the session of EIGRP route filtering. My name is Kedar Dandekar and I am a Cisco certified Internet Network expert in enterprise infrastructure. So if you have any question, then please feel free to mail me on kedardandekar@nittraining.in. So our first task is to configure the EIGRP classic mode on all the routers. After that, we have to configure the router 6 so that he will redistribute the directly connected LAN network, which is 172.168.1.0 into EIGRP. So first we will configure the EIGRP classic mode on router 1. So router EIGRP 10, and we have to advertise the network 192.168.0.0 and the network 200.100.0.0. Now router 2. So on router 2 we have to advertise the network 193.168.0.0 and 193.168.1.0. Also network 200.100.0.0, 200.100.1.0, 2.0, 3.0 and 4.0. Now after that router 3. So on router 3 we have to advertise the network 200.100.1.0 and 5.0. Now router 4. So on router 4 we have to advertise the network 200.100.2.0 and 6.0. Now router 5. So on router 5 we have to advertise the network 200.100.3.0 and the LANs network are 196.168.0.0, 196.168.0.0 and 197.168.0.0. So the network 196.168.0.0 and 197.168.0.0. Now router 6. So on router 6 we have to advertise the network 200.100.4.0 and now we have to redistribute the directly connected network, which is LAN network. So for that now we have to create the route map. Let's say connected, and now we have to match the interface that is connected to LAN 8. So router 6 interface is E0/0, which is connected to LAN 8. Okay. Now after that router EIGRP 10, and now redistribute connected route map, and we will apply this route map here. Okay. Now if we verify on router 2, let's verify the routing table. So we can see that on router 2 LAN network is receiving 172.16.1.0. This network is receiving on router 2 as a EIGRP external. Okay. Now router 7, router EIGRP 10, and now on router 7 we have to advertise the network 200.100.5.0 and 7.0, and the LAN 4 network, which is 194.168.0.0. Now router 8. So on router 8 we have to advertise the network 200.100.6.0 and 7.0 and LAN 5 network, which is 195.168.0.0. Okay. So we have configured the EIGRP classic mode on all the routers. Also on router 6 we have redistributed the directly connected network of LAN 8 network. Okay. Now after that we have to configure the route filtering on router 2 so that he will advertise the summary network for both LAN 2 and LAN 3 towards the router 5. Also router 2 must advertise the specific network of LAN 3. So the task is saying that router 2 must advertise the summary network towards router 5 for both LAN 2 and LAN 3 network. Also he must advertise the specific network of LAN 3, which is 193.168.1.0. Now if we verify the routing table of router 5, so let's verify first. If we verify the routing table of router 5, then we can see that router 5 is receiving the network of LAN 2, which is 193.168.0.0, as well as the network of LAN 3, 193.168.1.0. Now we have to advertise the summary network from router 2. Okay, and the task is saying that the specific network of LAN 3 should also be advertised. Okay, so for that now we have to create the access list, and we have to permit the LAN 3 network, which is 193.168.1.0. and now we have to create a route map. Let's say we will give the name summary and LAN 3. We will permit it, and now we will apply the access list here. Okay, and now interface E0/3. So my interface, router 2 interface E0/3 is connected to router 5. So we will configure the summary address on interface E0/3. So IP summary dash address EIGRP 10, and the summary address will be 193.168.0.0, and subnet mask will be 255.255.254.0, and we will apply the route map here. So summary and LAN 3. So this route map we will apply here. Okay, now let's verify it again on router 5. So if we verify the routing table of router 5 now, so we can see that router 5 is receiving the summary network, which is 193.168.0.0. Also he is receiving the specific network of LAN 3, which is 193.168.1.0. He is not receiving the specific network of LAN 2, which is 193.168.0.0. He is only receiving the summary address and the specific LAN 3 address 193.168.1.0. Now the next task is to configure the router 2 so that he will advertise the summary network for both LAN 2 as well as for LAN 3, but now towards router 6. Also router 2 must advertise all the specific network towards router 6. So the requirement is that router 2 must advertise the summary network towards router 6, as well as he must advertise the specific network for LAN 2 and LAN 3 also. So for that now again we have to create. So if we verify the routing table of router 6, show IP route EIGRP. So currently we can see that router 6 is receiving the LAN 2 network, also LAN 3 network. Both the specific network router 6 is receiving. So now on router 2, first we will create the route map, and we will give the name, let's say summary and all. We will permit it. Now after that we have to advertise the summary network. So interface will be E1/0, which is connected to router 6. IP summary dash address EIGRP 10, and summary address will be 193.168.0.0, 255.255.254.0 will be the subnet mask, and we have to apply this route map, summary and all. Now after that, if we verify the routing table again on router 6, now we can see that router 6 is receiving the summary network also, which is 193.168.0.0. Also he is receiving all the specific network for LAN 2 and LAN 3, 193.168.0.0, 193.168.1.0. Now after that we have to configure the router 1 so that it can filter the EIGRP routes that have the metric from 3,55,000 to 3,60,000. So the task is saying that this is router 1. So router 1 has to filter the EIGRP route that has the metric value from 3,55,000 to 3,60,000. So if we verify the routing table on router 1, show IP route EIGRP. So here we can see that the network of LAN 4 194.168.0.0 has the metric value of 3,58,000. Same for LAN 5, 3,58,400, and the network 100.7.0 has the metric value of 3,58,000. Okay, so the task is saying that we have to filter the EIGRP routes that has the metric value from 3,55,000 to 3,60,000. So for that we have to add these both the values, 3,55,000 and 3,60,000. After that whatever value we will be getting, we have to divide it by the 2. Same thing, we have to subtract these two values, 3,55,000 and 3,60,000, and whatever value we will be getting, we have to divide it by 2, and that both the metrics we have to, that both the values we have to match inside the route map. So let's do this. So route map, we will create it filter and we will deny. So match metric, and the value will be now 3,57,500. Okay, and plus minus, and second value will be 2,500. Okay, and after that we will permit rest all the network. So permit 20, and now exit router EIGRP 10, distribute dash list route map. We will apply this route map here in inbound direction. Now we will clear the EIGRP neighbors. Now let's verify the routing table again on router 1. So now here we can see that router 1 is receiving all the networks, but he is not receiving the network of LAN 4, LAN 5 and the network which is 200.100.7.0, because so previously we can see that, so here he was receiving the network of LAN 4, LAN 5 that was having the metric value of around 3,58,000, and the network 200.100.7.0 was also having the metric value for 3,58,000. So now he is not receiving those three networks. Okay, so router 1 is filtering those three networks of LAN 4, LAN 5 and the network 200.100.7.0, because their metrics are coming between 3,55,000 to 3,60,000. Now after that we have to configure the router 4 such that it will not receive any external EIGRP routes. Okay, so this router 4. Okay, so router 4 will not receive any external EIGRP routes. So let's verify the routing table of router 4 first. So IP route EIGRP. So router 4 is receiving the external network which is 172.16.1.0. Okay, so the task is saying that router 4, configure router 4 such that it will not receive any external EIGRP route. Okay, so we are not allowed to configure any access list, prefix list and route map here. Okay, so for that now we have to configure the command. So we will increase the ED value of external route. So router EIGRP 10, distance EIGRP 90, and for external EIGRP routes we will configure it 255. So let's clear the EIGRP neighbors again. So if we clear the EIGRP neighbors, so let's verify the routing table again. So if we verify the routing table again, now we can see that router 4 is not receiving any external EIGRP network. So previously router 4 was receiving the LAN 8 network which was external 172.16.1.0. Now router 4 is not receiving any external networks. Okay. So thanks for watching the video. If you have any question, then please feel free to mail me on kedargandekar@nittraining.in. Thank you.